Good evening, children. So once again, yes. So once again, you can, what is it? Welcome to our 1 mark solution. You can like, share, and subscribe. Again, I'm telling the importance of MCQ, children. Now we are going for this electromagnetic induction fourth unit, assertion and reason. The remaining of the assertion and reason, and based on the theory what we are studying in the electromagnetic induction and AC. Electromagnetic induction is one chapter and AC is another chapter, but together we can say 1 unit. It is coming under 1 unit. So what is AC? You know that alternating current, isn't it? If alternating current, how we are getting alternating current? From this process of electromagnetic induction. Now, let us start with the first one. Inductance coil are made up of copper. Inductance means what is it? The coil itself. The property of the coil, we'll call it as inductance. It is made up of copper. Then we can say induced current is more in wire having less resistance. Why copper is used? Do you know that why copper is used? Why? Because it is having less resistance. We know that in our home, isn't it? In any buildings, you can say that connecting wires, all we are using copper, right? Best conductor, we can say silver, but we can't use it. It is very expensive. That is why we are using copper. And the second one, induced current is more in wire having less resistance. That is also correct. Why? Because what is the current equation? What is the equation for the current? I is equal to V by R. Instead of V, we can use induced EMF, small letter E by R. Okay. So here we can say the assertion as well as the reason also true. And the correct explanation. Why it is correct explanation? We are pointing about the copper also. So copper is having less resistance. That is why we are using it. So the option is A. The option A. Now we can go for the second. When two coils are bound on each other, the mutual induction between the coil is maximum, one over the other. If we are taking one coil and we are just winding one over the other, we can say that what is happening if one coil is just winding like this, and if you are winding another one over the other, we can say what is it? It will be maximum. Mutual induction will be maximum. Why? Because distance is very, very less. Then, so assertion is correct. What about the reason? Mutual induction does not depend on the orientation of the coils. Can we say like that? Mutual induction does not depend on the orient of the coils? No, not at all. It depends on the orientation. We can say that if it is orienting, what is happening? The angle also changes. If the angle changes, sure, flux will be changes. What is the relation between the angle and the flux? Phi is equal to, you know that the letter phi, isn't it? Phi is equal to, we can say that phi is equal to BA cos theta. Phi is equal to, we can say BA cos theta. B is a magnetic field, A is the area, and theta is the angle. So whenever there is an orientation, angle also is changing. So the reason is wrong. Assertion is correct and reason is wrong. So the option is C. Let us move on to the next one. We can say that third one. What is the third one? An electric motor, again the motor comes, will maximum efficient when back EMF is equal to the applied EMF. Same sentence we have discussed it. Efficiency of the electric motor is depends only on the magnitude of back EMF. Here we can say both assertion and reason is false. Now let us move on to the fourth one. We can say assertion, a spark occur between the poles of a switch. When the switch is opened, a spark, we know that when the switch is open, sometimes the spark will be occurring there, right? You have seen that. Reason, what is the reason? Current flowing in the conductor produce magnetic field. Is it the reason for the assertion? No. Current will produce sure magnetic field. Due to this magnetic field, can you say the spark will be there? No, not at all. So both are correct, but the reason is not the correct explanation for the assertion. So that what is the option? We can say option B. Now we can go for the option, next assertion and reason, fifth one. In the phenomenon of mutual induction, self-induction of each of the coil persists. That we know that. Anyway, if mutual induction is there, self-induction, that means if two coils are there, self-induction will be there. Sure. Reason, what is the reason? Self-induction arises when the strength of the current in the same coil change. In the mutual induction, current is changing in both the individual. So what is the assertion given is the process of mutual induction. In that, self-induction is persisting. That means it is there. That is correct. And reason given is also correct. But we need the explanation of the what is the process of mutual induction. But it is not giving here. So what is the answer here? The option B. Read the assertion and reason carefully. Why? Because the options is it is given in that manner. So here we can say the option is B. Let us move on to the next one. An induced EMF is generated when magnet is withdrawn from the solenoid. You know that when magnet is withdrawn from the solenoid, an EMF is generated or not, you should know that. When the magnet is moved, what is happening? No change in magnetic field, isn't it? So there is no induced EMF. But when it is moving, when it is moving at that time, change in magnetic field will be there and EMF will be generated. So you should be very careful. The basic thing is, whenever there is a change in magnetic field, either the movement of the magnet or the change in current, an EMF is induced here. What is the second, the option statement we can given as reason? The relative motion between the magnet and the solenoid, induced EMF. The relative motion, why the induced EMF is produced? Because of the relative motion. That is correct only. If there is a relative motion, then only we can say EMF will be induced. The magnet is moving, isn't it? Either the magnet or the solenoid, if you are moving, you will get the induced EMF. So the answer is option A. And you have to be very careful, children. Magnetic field is changing, then only an EMF is induced. That words you have to always recollect it. Okay. Either you can change the position of the magnet or you can change the solenoid. Either you can move magnet or you can move solenoid or you can change the current. This all produces the change in magnetic field. So an EMF is induced. EMF. What is EMF? Electromotive force. To motivate the electron, we are using this force. So here the option is A. Now we can go for the seventh one. A transformer can't work on DC supply. No doubt at all. Nothing to say actually. Why? Because transformer, what is the principle of transformer? Mutual induction. That is the principle of transformer. So if you want to conduct or if the process takes place, the mutual induction takes place only when there is a change in magnetic flux. If DC is connected, can we say that there will be a change in current? Change in magnetic field? No. So assertion is can't work on DC supply. Correct. Now we can go for the reason. DC changes neither in magnitude nor in direction. Absolutely correct. So the reason is the correct explanation of the assertion. What is DC only you have to say. Why? Because if it is AC, transformer will work. And if it is DC, there is no change in current or no change in direction also. So the option is A. Now let us move on to the eighth one. Soft iron is used as a core of the transformer. That is correct. Assertion is correct. No doubt. Soft iron is used. What do you mean by core? What is core actually? At the center, what we are placing, we'll call it as core. Okay. Now, transformer. In the transformer, why we are using soft iron? Can we use another substance? No. Another material? No. Why? Because this soft iron reduces the loss. Which loss? Hysteresis loss. What do you mean by hysteresis loss actually? What do you mean by hysteresis? Hysteresis. You can see the spelling here. Hysteresis. It's not history. It is lagging behind. Due to the lagging behind, you will study in the magnetism chapter BH curve. Magnetic field and magnetic intensity. A curve is there. There we are drawing a, hysteresis loop. In that loop, you will get area. If the area is increasing, the loss will be increases. So we are considering soft iron and steel. We can say in the soft iron only, the energy loss will be less. Why? Because area is very small. So why soft iron is used in transformer? Answer is the area of the hysteresis loop is very small. If the area is small means loss is very small. The energy loss is very small. So what is answer? Assertion, and reason is true, and the reason is the correct explanation of assertion. So what is the answer? We can say A, option A. Yes, now you can see that. Now we can go for the ninth one. An aircraft flies along the meridian. The potential at the ends of the wing of the two wings will be the same. No, not at all. Here we can say if it is flying like this, potential will be different, and you can study from the motional EMF is equal to BLV. So that reason, what is the reason here we can say? Whenever there is a change in magnetic flux, EMF is induced. That we know that. But in the assertion, we can say the potential is same. No, it won't be same. So assertion is wrong. And the reason is absolutely correct. So the option is E. New option is also there. See? A, B, C, D, E option is also there. That option is here. Assertion is false and reason is true. Next one we can say 10th question. An AC generator. Two devices you are studying in these chapters. One is AC generator, another one is transformer. Both are very, very important. What is the principle of AC generator? Electromagnetic induction. The chapter name itself is the principle of AC generator. That you can think in that manner. You can recollect in that manner. What is the principle of transformer? Mutual induction. If you are writing electromagnetic induction, that is not correct. The correct word should be there, that is mutual induction. So an AC generator is based on the phenomenon of self-induction, we can say. Is it correct or not? AC generator, we can say it is electromagnetic induction. Now we can go for the reason. In single coil, we consider self-induction also. Only correct. Reason is correct, isn't it? No doubt. In single coil, we will consider self-induction only. But the assertion, it is false. Why? Because AC generator, they are telling about the self-induction. I told you, you should write electromagnetic induction. Then only the principle will be there. What do you mean by electromagnetic induction and self-induction? Almost same. But you should write the principle of AC generator electromagnetic induction. So the first one, assertion is false and the reason is true. The option comes here, E. That's all. Thank you for watching, children. Thank you.